Good morning, everyone, and I welcome you once again to the numerical class of electrostatics. And in this class, again, someone got me a problem saying 2-point electric charges of values q and 2q are kept at a distance d apart from each other in air. A third charge q is to be kept along the same line in such a way that the net force acting on q and 2q is 0. Calculate the position of charge q in terms of q and d. So we will be doing a freehand diagram which will draw first. So when we draw a freehand diagram, it's a 2-point electric charges of values q and 2q. Okay, 2-point charges. The 1 point is here. This is q, and other point is here. This is 2q. Are kept at a distance t apart. Now the distance from here to q to 2q is d. D. And it's in air. A third charge q is to be kept along the same line in such a way that the net force acting on q and 2q becomes 0. Let this point here we add q so that they equal to the net force becomes of a system is 0. Then I make a statement here for equilibrium is saying that for equilibrium of charges q and 2q, of charges q and 2q. Okay, here charge q and charge 2q. The charge q must be let this charge be capital Q. So q and 2q, the charge q must be of sign opposite to the q and 2q. I made a first statement here. For equilibrium of charges q and charge 2q, charge q must be of sign opposite to that of q and 2q. If not, it will not be equilibrium. So for all problems coming across, you should remember that the charges which are placed in between, they must have opposite charge to maintain it in equilibrium. Now for equilibrium charge q, second statement is for equilibrium of charge q, this must be here it should be this equals k and qq upon x square if this distance is taken as x. This is x. then of course this distance will become d minus x. This distance becomes d minus x. Now this is equal to, for equilibrium, so this will again become k 2q, that is q into 2q upon d square. Let this be your first assumptions. For equilibrium of charge q, here k q by x square, here q to this q upon distance is x square is equal to k full system 2q by this is first. Now furthermore we can have a step here, one of the second, for equilibrium charge at 2q, for equilibrium of charge 2q, again we will have k q into 2q. Now between q and 2q the distance is d square, and this will become k into q into 2q upon d minus x square. This is your second assumption. Now from 1 and 2, equation 1 and equation 2, since the equation 1 and 2, we'll be writing here k q by x square is equal to k q into 2q upon d minus x square. Now solve this equation, you will get 2x square is equal to d minus x whole square, or 2x or root 2x is equal to d minus x, or root 2x plus x is equal to d, or x is common, so you get root 2 plus 1 is equal to d. Or you can have x is equal to 1 upon root 2 plus 1 into d. Or this can be written as root 2 minus 1 into d. Now the charge q must be placed at a distance of root 2 minus 1 d from the charge q so that their net force becomes 0. I repeat it quickly to you. There are two charges q and 2q kept at a distance d. A third charge q is introduced at a point so that the net force of a system becomes 0, and this is what the question requires to be satisfied, that they maintain the equilibrium position. For equilibrium of charges q and 2q, the charge q must be of sign opposite to that of q and 2q. For equilibrium, you have k qq, k qq, this is the first one, and the new charge that you have introduced by x square, this distance is x square, is equal to kq into 2q by d square. Now this is your first equation. Now for equilibrium of charge 2q, kq into 2q by d square, so is equal to kq into 2q by d minus x square. Solve the equation and you will get it, x is equal to root 2 minus 1 into d. If you want this part, some people have a confusion here at this point, so let me solve here. From here you have got here x is equal to 1 by root 2 plus 1 into d. What you do, you multiply it like this, root 2 minus 1 by root 2 minus 1. This becomes root 2 minus 1 into d by a plus b into a minus b, so you get 2 minus 1. This satisfies that x is equal to root 2 minus 1 into d. For any further queries, please contact Kumar Lal 9478624982 or keep mailing me at prashantlal1961@gmail.com. Thank you very much.